Hi everyone, welcome to the demonstration video for part 4 of homework 2, where we are going to talk about how to set up hourly plots that are generated in Ladybug, Tools, and Grasshopper and shown in Rhino. So to do that, let's turn off all of the visualizations from Grasshopper into Rhino. So I'm going to say Control A, right click in the canvas and say preview off. And then I'm going to go over here to the view indoor and outdoor temperature results, and I'm going to visualize this hourly plot. So I'm going to right click and say preview on, and then go into the top view. And you should be seeing an hourly plot that we viewed in class. Up above, you'll see the hourly temperature results from the weather file, the outdoor hourly temperature results. And then on the bottom are the indoor hourly temperatures results for your single family home that doesn't have mechanical heating and cooling. You'll see that I have my set condition zones to off. And in order to view these results, remember that you need to turn this toggle on to true, the run energy model toggle on to true, so that these results are generated and active, so that they can be displayed in Grasshopper or in Rhino. Okay, so we're going to be going over how to create this kind of chart. So I'm just going to move this group over here, and I'm going to hide this. So I'm going to select this and turn the preview off. Okay, so the first thing that we need to do is we need to grab the results from the energy model, from the energy simulation. So after you run an energy simulation, if you go into this component, you'll see that an SQL file is generated, and this contains all of the hourly results for the energy usage. So the heating, cooling, lighting, electrical equipment, all of the hourly energy results for that. And it also has the interior indoor temperatures and a lot of other comfort metrics that we aren't going to use, but that could be helpful if you're doing a different type of analysis. So let's go to the Honeybee Energy tab and go to a component that will help us grab some of the simulation results from this SQL file. So the way we do that is go to the Honeybee Energy tab, then go down to results and select this Honeybee Read Room Comfort results. So I'm going to left click on that, left click in the canvas, and we'll see that this says that it parses all of the common room level comfort related results from an SQL results file that is generated from an energy simulation. Okay, perfect. So this is from our energy simulation, and this is the SQL file that we want, and we're just going to put it into there. So you'll see that it's going to output some comfort results. Operative temperature, the mean operative temperature of each room, the air temperature. So the difference between these two is that this is the actual air temperature, and this is the temperature that it is set to, basically what the set point is set to. This is the mean radiant temperature. This is the relative humidity. These are the hours that the heating set point is not set, and these are the hours that the cooling set point is not set. We're just interested in this air temperature. And if you hover over it, you can see it says it's one locally defined value, hourly continuous data collection. So it's an hourly collection of data of the mean air temperature, and you can also see that it says it's in Celsius. So to plot hourly results, and it doesn't only have to be air temperature, it can be any hourly data collection, we can go to the Ladybug tab and then go to Visualize Data and select LB Hourly Plot. You can also search for this component by double left clicking in the canvas and typing hourly plot, and you'll see LB hourly plot. Okay, so in order to run, the only required variable, which if you remember, are variables that only have an underscore in the front. So for all Ladybug tool components, in order to run, they only need the variables that have an underscore only in the front. So in this one, it's only the data variable. And it says that it wants a hourly continuous collection or hourly discontinuous collection, which will be used to generate an hourly plot. So that's what we have here. This is an hourly data collection. So let's plot this and see what it looks like. Okay, so you can see that something has been generated in Rhino if this is set for the preview on. And it is the zone mean air temperature for our home zone for the whole year and for every hour of the year. And you can see that there's a temperature range, and you can see that the results are in Celsius. However, we are going to be reporting the results in Fahrenheit. The default output is usually going to be in metric units, but we want them in imperial. A quick way to convert data collections into imperial is using a component under the Ladybug tab, under extra, that is called Ladybug to IP. So if you left click there, left click on the canvas, and pass your hourly data collection of the air temperature to this input where it says data in SI. This is a data collection in SI units, which this is, it's in Celsius. It will output your data collection in imperial units. So let's see what that does. Let's swap this data for our input for hourly plot. You'll see that now it says Fahrenheit. Cool. So that is what we want. We might be happy with this. This is giving us a lot of information. It's giving us the range here of values of indoor temperature throughout the year. So inside of our home, it's going from 19 degrees Fahrenheit to 107. That is a big range and an uncomfortable range. So hopefully through the next few weeks, you'll be able to get your house a little bit more comfortable. This might be great. And this gives you a lot of information. It tells you what times of the year you want to focus on. And it just by looking at it, it gives you kind of a clue as to how much of the year you're above kind of your comfort range and how much of the year you're below your comfort range. So this gives us a lot of information. One thing you might want to do is change the legend parameters so that you can set this range yourself. So it's not always going to show the min and the max of whatever data set you pass to it. The way to do that is you can go to the Ladybug tab, go to extra, and then you go to Ladybug legend parameters. And you'll notice that this component, Ladybug legend parameters, has an output called legend parameters, and our hourly plot has an input called legend parameters. They're referring to the same thing. And if you hover over this, it kind of gives you a clue that it wants a legend parameter object. And this is a legend parameter object that can be plugged in to any of the Ladybug components with legend. Perfect. So these are the same thing. So I'm gonna connect those. And you can see that from this legend parameter object, we can set a min and a max. So you can choose a min and max that makes sense for you for what kind of data you're trying to display. But what I'm going to do is I'm going to change my min to 30. And I will change my max to, I'm just going to copy what I had before. I can't remember, 100. Okay, 100. Oh, and I should mention that I created this slider by double left clicking and just typing a number. So I'm going to type in 100 and hit enter. And you can see that now my min and my max have changed. So you can use the slider to change your min and max by sliding. You can also double left click in the slider and change the number by typing it and hitting enter. But yeah, so this, let's say this is an appropriate range for you. You know that this kind of gives you a clue as to like kind of a good range of values throughout the year of what your indoor environment is feeling like. And if it is going to be under 30, it's going to be this color, the lowest color. And if it's over 100, over your max value, it's going to be this color. Okay. And then speaking of colors, you can actually change the colors as well to make them a little bit more intuitive. This is already going from blue is cold to kind of like a more warm, moving up to kind of like a more warmer tones for the hot. So that might make sense. Or you could leave it like this if you wanted to. Or you could change the colors yourself by defining a color set. So if you hover over the colors option, it'll say it just wants a list of colors. And the default is the Ladybug's original color set. So one option for passing colors into here is just passing a list of RGB values. And that is what I have in your homework instructions. So these are a list of RGB values, and they correspond to kind of a blue, to a more like to white, and then to red to match the that matches the range of colors that was in the original hourly plot. So let's take a look at it. So if you double left click, I just put in a panel. So if you go to params and then choose panel and left click to put the panel in, double left click in there and then say Control V, you'll see all of those colors have been brought in. Left click outside of the canvas, and then we want to turn this into a list of data. So if you right click and say multi-line data, this will become a list of colors. And this is going to be in, this is in a organized in a way that this component will understand because it wants a list. So we are going to pass these colors to this list. And you'll see that now the colors are going from kind of a dark blue to a white, where we're in the comfort range, and then back to a red. Great. And then one other thing that you can change is the segment count. So let's drop another slider by double left clicking in the canvas and saying 15. And let's connect that to the segment count. And you'll see that the number of segments changed. And you can change the number of segments by sliding your slider and making them bigger or smaller. I chose 15 because with the range of 30 to 100, that creates steps of 5 degrees Fahrenheit. Okay, so that is how I created the hourly plot of the indoor temperature data. If I wanted an hourly plot of the outdoor temperature data, I could grab that from the weather file. So let's practice doing that. This is our weather file right here, our EPW file, and all of the outdoor temperature data is stored in this file. And we can access that with a Ladybug component. So if you go to Ladybug and then go to import, we can use this Ladybug import EPW to look at the hourly temperature data for the outdoor, for outdoors. So I grab that component, I'm going to drop it in the canvas, and then I'm going to pass the Energy Plus weather file to it. That's what it wants. And then you can see that all of the components of the weather file are available to us. And one of them is dry bulb temperature. That's the outdoor temperature. You can see if you hover over it that it is the hourly dry bulb temperature in Celsius. Let's pass this dry bulb temperature to this component. You can see that the chart was updated, and now this is showing the outdoor temperature results. So you can just practice switching between the indoor air temperature by going like this, selecting the air temperature from the Honeybee Read Room Comfort results and passing it to this component that converts from SI to IP, from imperial or from metric to imperial. And then that ultimately gets passed to the component that plots the hourly data. So you can see the difference between the files or the temperatures this way. If you want to see them together, plotted together, one thing that you can do is you can bring them into this component together. So you can do that by hitting Shift. And what that does is it adds the inputs instead of replacing them. And another thing that we need to do, because these are not on the same, not in the same data location. So I don't know if we've gone over this in class yet, but up here, this kind of gives the address of where the data is stored, and this is stored in the 0 branch. This is stored in the 0, 0 branch, so they're not in the same data location. So what we need to do is we need to bring them into the same data location by flattening. We will go over this in class, we may not have already gone over this, but just know that we'll talk about it in class, but an easy way to fix this issue is to flatten. So basically, this is, now that they're flattened, two different data, pieces of data, pieces of individual data that are being listed. And then when we pass a list to this hourly plot, a list of data that is in the same data branch, it will run the operation 2 times. So that is what happened here. So we are seeing the outdoor temperature up above, and then we're seeing the indoor temperature down below. So that is what we've built the same as this. And you'll see when I grab this or highlight it, there is a line going from here to here from this component. This component's output is going to the hourly plot, but it's also going to down here where we're calculating the view percentage of time indoor and outdoor temperature results are in ranges. So if we wanted to just keep this set of components and not this set of components, we would have to bring this data from here now into here. So replacing it. We are not adding it, we are replacing it. And then we can actually just delete this because we don't need it anymore. We have it here. And we could label this by double-clicking in the canvas and getting a scribble. And to double left click on that scribble, make it bigger, and then say graph hourly temperature results. I made that bigger than these. I'm gonna see what, okay, these are size 35. So this size 35. And then I'm going to right click in this group and say make color default. That makes this color for this group the default color. So next time I group, it's going to be that color. So I'm going to select all of these components and say Control G. I could also select all of them, right click in the canvas and say group to create a group. And now I have my hourly plot set up. And that is it for homework 2. So just go ahead and save your Grasshopper file. I'm going to save it with, you can save it however you like, but I'm just going to put my initials at the end of it. And upload your Grasshopper file that you edited and your Rhino file into Canvas to finish up this homework assignment.